Hello, this is the video presentation of our team completing the Grand Challenge 1, which is the genome assembly. So for this task, our M50 score was exactly 1,500 out of 50,000 data. Um, the reason why we didn't complete the whole data will be explained later in this video. So let's start with our solution. And in this PowerPoint, we gathered, um, I believe, 6 pieces of our code, including one which is the calculation of the precise N50 codes. That one is just a calculation um, function. But the rest of them are our original codes from our um, ideas of solving this problem. So when we first got to thinking about how to solve the general assembly, we thought of the graph problems from the class, especially the shortest path algorithm we did for a few weeks ago, or actually we're constantly doing it. But in this case, we're matching or we're comparing the overlapping genomes or readings to be precise. And so the shortest path algorithm need to be adjusted so it kind of form to one we call the longest path. So we need to basically what we mean by that is we need to find the most overlapping ones, and the repeated one or the self-looped ones will be set to 0. So let's start off with the rest of our functions. So the first function is calculating the overlapping length from read 1 to read 2. Uh, this is really like very similar to the graph problems. To be very clear for understanding, we wrote a lot of comments right next to these codes, so that helped. Uh, we hope that will help explain our functions more clearly. So that's the first one. It's just for calculating the overlapping length from read 1 to read 2. We give 2 specific examples of how that would work. And the second one is reading the .fq file from the Moodle and create a graph basing on all the reads. So we also give 2 examples of 2 reads which have the overlapping readings. And then the graph generator, the function will return uh, the data below. So we can create a graph with read is not, and we have the weights, which is also the overlap. And in other words, the graph 0 to 1 is overlap value from read 0 to read 1. And the third function is combining the subgraph into result graph. And you use multiple if statements. At first, we use the if statements to get the picture clear, stating that if there is no subgraph in the rest function. And the next one is the function creating a result graph containing all maximum cortex. and it would pick the largest overlap value of VU as a subgraph and add it into the result. Also, we would like to reset those values to 0. And if the termination U existed, and we should ignore that and set the values to 0 again. And the next one is the function which returns the cortex in the order of the length. So um, with all the calculation of the overlap, we actually need to it's just a function to sort like the values we got. And the final one function is what I mentioned earlier. Is to return the N50 value from this calculator. Um, it was sort of a technical difficulty. We ran our whole function on the Jupyter lab, so we didn't get the chance of um, getting all the data down. Instead, so to actually get an N50 um, value, we actually extract 50,000 data from all the data sets, and 1,500. That's the score we got, and we think that would actually match the um, a good what is called a good result for the whole picture. So if you ask me, um, what can I do if I have more time with this whole project, I would just say that like we would definitely uh, going to wait until we get the final result from the data set. But due to that technical difficulty and time difficulty, we did not get the chance of finishing all the data. But that N50 value 1,500 should give you guys a clear view of uh, that our algorithm is good enough to solve this challenge. Thank you.